All right, strap in, everyone. Today we're going deep, really deep, into the many worlds interpretation of quantum mechanics.
Whoa, yeah, diving headfirst into MWI.
You know how much our listeners love this stuff, and we've got some awesome excerpts from an academic paper on the topic.
This is where quantum physics gets really trippy.
It's like, hold on to your hats, because we're talking about the possibility that every single choice, every possible outcome, could actually be happening in a separate universe.
It's wild. And to think this isn't just science fiction, this crazy idea actually comes straight out of the equations of quantum mechanics.
Right. Okay, so before we launch ourselves into the multiverse, maybe we should do a quick recap. What is quantum mechanics all about? Why is it so weird and different from the physics of our everyday world?
So quantum mechanics, it's basically the rule book for how matter and energy behave at the tiniest scales, like the level of atoms and the particles inside them.
Okay, so not like throwing a baseball or driving a car.
No, not at all. At these tiny scales, things get really bizarre. One of the key concepts is this thing called the wave function.
Wave function? What in the world is that?
Well, you can think of it as a mathematical description of a quantum system's state. Let's say we're talking about an electron. The wave function tells us about the probabilities of finding that electron in different places or having different properties.
So instead of saying the electron is right here, we're saying there's a chance it's here, a chance it's there. It's all about possibilities.
Exactly. It's like rolling a dice, you know? Before you roll it, you have all these possibilities, but you don't know which one will come up. And then there's the Schrödinger equation. This is the math that describes how these probabilities, the wave function, changes over time.
So Schrödinger's equation is like the rule book for how these quantum possibilities play out.
Exactly. Now, things get even weirder when we try to measure a quantum system. The traditional view of quantum mechanics, what's called the Copenhagen interpretation, says something really wild happens.
This is where I feel like things are about to get spooky.
It kind of is. The Copenhagen interpretation says that when we try to measure a quantum system, its wave function collapses. It goes from representing a whole bunch of possibilities to snapping into a single definite outcome.
Hold on. So before we measure it, the particle is like this blurry cloud of possibilities, but when we look at it, boom, it suddenly decides what it wants to be.
Yeah, it's kind of like that.
But what does it even mean for the particle to be in this weird, blurry state before we measure it? Does observing it somehow force it to choose?
That's the million-dollar question. And this is where the Copenhagen interpretation kind of throws its hands up and says, don't worry about what's real before you measure it. Just focus on the results. But you can imagine that leaves a lot of people unsatisfied. Like, does our observation actually create reality? What's going on before we look?
Yeah, that would keep me up at night. So this is where the many worlds interpretation swoops in with a completely different perspective.
Exactly. Hugh Everett, the physicist who came up with the many worlds interpretation, thought the idea of wave function collapse was a bit too weird. He said, what if the math is just telling us what's actually happening?
So he thought maybe all these possibilities described by the wave function are actually real.
Precisely. Everett's idea was that instead of collapsing into one outcome, all the possibilities embedded in the wave function actually happen. But here's the kicker. Each possibility branches off into its own separate universe, a universe where that specific outcome occurred.
So you're saying there could be a universe where I decided to become a musician instead of a podcast host, a universe for every possible choice.
Yeah, it's a radical concept, I know. It's like
Yeah.
the universe is constantly splitting, creating a vast multiverse where every single possibility plays out somewhere.
Wow, I think I need a minute to process that.
Yeah.
So we're not just talking about parallel universes, but an infinity of universes, constantly branching out with every quantum event.
Exactly. But how does it all work? How come we don't experience these other universes? That's where the concept of quantum decoherence comes in.
Okay, decoherence, break that down for me.
Well, quantum decoherence is what prevents the different branches of the universe from interacting. Think of it this way. You have two ships sailing side by side, but eventually they drift apart on different currents. The different branches of the universe become so entangled with their own separate chains of cause and effect that they can't interact with each other.
So it's not that these other universes aren't real. It's just that they're completely inaccessible to us. They're like ships that have sailed beyond the horizon, each on its own journey.
That's a great way to think about it. Each universe becomes isolated, evolving independently of the others. And in MWI, measurement isn't this special thing that changes reality. It's just another interaction, like two particles colliding.
And that interaction triggers the creation of these separate non-interacting branches. No collapse, just constant branching.
You got it. And you know what? That leads to some pretty mind-blowing implications. But before we get into that,
Already on the edge of my seat. This is incredible stuff, but we're going to have to take a quick break. Stay with us. We'll be right back to delve deeper into the many worlds interpretation and what it means for our understanding of reality. And we're back. Still trying to wrap my head around this whole multiverse thing.
yeah, it's a lot to digest.
Okay, so you were saying that MWI has some pretty wild implications. What are some of the biggest ones?
Well, one of the most intriguing implications is the idea of determinism.
Determinism. Wait, you're not saying our fate is predetermined, are you? Like free will is just an illusion.
That's a big philosophical question, for sure. But in the context of MWI, determinism means that the evolution of the wave function, which includes all those possibilities, is actually governed by a deterministic equation, the Schrödinger equation.
So there's no randomness in how the wave function itself evolves.
Yeah.
But then where does the randomness in our lives come from? I mean, it certainly doesn't feel like everything is predetermined.
The apparent randomness we experience comes from our limited perspective. We only experience the choices we make in our particular branch of the universe. We're not aware of the other branches where other versions of ourselves are making different choices.
So there's a me out there who decided to become a chef instead of a podcast host, and another me who's a rock star.
You got it! Every possible version of you exists somewhere in the vast multiverse.
That's both amazing and kind of terrifying. It makes you wonder if our choices really matter, if every possible outcome is already happening somewhere.
It's definitely a mind-bending concept. But instead of seeing it as diminishing our choices, maybe we can see it as emphasizing the uniqueness of our own individual journey.
Okay, I'm starting to see how MWI can shift our perspective. But there's another question that's been bugging me. If all these other universes exist, shouldn't we be able to see them or find some evidence of them?
That's one of the biggest challenges for MWI. The different branches of the universe, they become so isolated from each other, so entangled with their own environments that they're basically inaccessible.
So, no chance of hopping over to the universe where I'm a famous astronaut.
Not likely, at least not with our current understanding of physics. But while we might not be able to visit these other universes directly, some physicists think there might be subtle quantum effects that could provide indirect evidence for MWI.
So the search for clues continues. It's like a giant cosmic detective story.
Exactly, and it's a story that could lead to profound changes in our understanding of reality.
So to sum it up, we've gone from a picture of reality as this single fixed timeline to a view of reality as this vast, constantly branching tree of possibilities.
A multiverse where every possible outcome actually plays out somewhere.
It's almost too much to comprehend.
It certainly challenges our conventional view of the world, but then again, that's what makes it so exciting.
This has been one mind-blowing deep dive. I think I need a moment to process all of this. We'll be right back after a quick word from our sponsors. All right, we're back. I don't know about you, but I'm still reeling from all this talk about the multiverse.
It's definitely a lot to wrap your head around.
So we've explored quantum mechanics, wave function collapse, the Copenhagen interpretation, and this mind-blowing many worlds interpretation. Where does all this leave us? What does it mean for us? For our understanding of reality?
Well, that's the big question, isn't it? If the many worlds interpretation is actually a good description of how reality works, does that change how we should live our lives? Does it change anything at all?
Right. Does it make our choices more meaningful, knowing that every possibility is playing out somewhere? Or does it make them less meaningful, because it's like everything's already happened in some other universe anyway?
It's definitely a question worth pondering. It challenges us to think about what it means for something to be real, what it means to have free will, and ultimately what it all means for our place in this vast, maybe even infinite universe.
I mean, the idea that there are countless other versions of me out there, making different choices, living completely different lives, it's both exhilarating and terrifying at the same time.
I get it. It's a lot to take in. On one hand, it's like, wow, there's a universe where I'm a rock star or an astronaut. But on the other hand, it makes you question if any of our choices truly matter.
Yeah, it makes you wonder if everything is already predetermined, if we're just playing out a script that's already been written.
It's a deep philosophical rabbit hole, that's for sure. And there's no one right answer.
Maybe it's not about finding the right answers. Maybe it's just about asking the right questions.
That's a good point. The many worlds interpretation, whether it turns out to be the correct picture of reality or not, it pushes us to expand our thinking, to confront the limits of what we know, and to embrace the mystery of the unknown.
And that's what makes this all so fascinating, isn't it? The fact that we can use science to explore these big questions about the universe and our place in it.
It's an incredible journey of discovery. And even if we never find all the answers, the process of searching for them can change us, can make us see the world in a new light.
Well said. So to all our listeners out there, keep exploring, keep questioning, keep your minds open to the possibilities, no matter how mind-boggling they might seem. Maybe there's a universe out there where everyone is listening to this podcast right now.
Now that's a thought.
Thanks for joining us on this deep dive into the many worlds interpretation. We'll be back again soon with another fascinating topic, ready to explore more of the mysteries of the universe. Until then, stay curious.